that go? All right, there's YouTube is up. Okay, there we go. Everything seems back up. I don't know if you're still here. Yeah, okay. Um, all right, it's all good now. So, yeah, maybe like my router's getting too hot after I turned off my air conditioner, but I remember seeing like on my phone earlier told me like sign into the network for a moment and then it fixed itself. So maybe AT&T is just having problems where I live right now. Anyway, should be fine now. So, yeah, I was trying to figure out this prefix sum stuff. Um, and so like I can do instance count minus one, but that's not quite right, right? So like if I think about this, if I have, let's say I have a draw right here. So let's just say draw command 2 dot first instance, and this is what is this index? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So your first instance is 9, and your instance count is 2. 2, right? So that should be 1, 2, right? So you should go to 9. Okay, yeah. So since I'm doing plus 1, then that's going to be 10, 11. Yeah. So yeah, I think yeah, this probably has to be minus 1 then. I don't see how else it could work. Maybe the maybe this code is actually broken and it's returning the wrong instance count. Maybe, but I'm pretty sure this has to be minus 1. Like it doesn't make. Oh yeah. Well, I'm doing minus 1 here anyway. Yeah. Okay, that'll make sense. So this definitely has to be minus 1. And now, yeah, and then we're checking if the instance count is 0. Yeah, then just return 0. That's fine. Right. Really, I wish I could like talk back to the CPU and say like, hey, there's a problem here. Because really this should never happen, but whatever. And oh yeah, I think there's some. Maybe I'm just making this up, but I thought I saw something about like some Vulkan extension for like reporting errors from shaders back to the CPU or something. I don't remember. Or maybe it's something weird with like query parameters. I'm not sure. Anyway, that's kind of besides the point. So it's definitely minus 1 because that makes sense, right? Because then we'd be doing 9. Yeah, we'd be checking. Yeah, right. I'd be checking. Well, here actually, there's a printf extension. Okay, yeah. I knew there was something. Yeah, so maybe I could like do printf in here and tell the CPU, hey, this should not be a thing. Yeah, I don't know how slow. I mean, well, yeah, it should just be like one equality compare and then like a jump instruction or something, or yeah, return, or yeah, like one equality compare and then just like skip over it with a stack pointer or something. Just trying to see how slow this test would be, but I mean, I have this here as well. It shouldn't be terrible. Anyway, yeah. So first instance plus instance count minus 1. This is right because then I would say like 9, and then I just do like 9 plus 1, so that would be 10, and that would be the last one, and that is where I want to be looking. So that's good. So this is the total of the prefix sum of including all of the instances that should be drawn for this draw command. And now basically what I want to do is subtract out all of the instance counts that are not a part of this draw command. And that's what I'm trying to do here with first instance, but maybe that's not right. So if I look here with draw command.first instance, right, So like if we look at 9 here, right? So this is 9. And then I would be doing 7 minus 6, which is 1, which is correct. Like maybe this is actually right, and this code is actually wrong. I don't know. Yeah, but I think definitely if I have minus 1 here, that should stop the crash from happening at the end. And then this should fix it at the beginning. So maybe this is actually right. Shouldn't it be first instance minus 1? No, I don't think so. 1, because in the case of first instance equals 0, which is totally valid, right? Because it can just be the first thing in like the list of instances, the first like collection of instances. And 2, like if I'm just looking at the math here, I want to do like 7 minus 6 equals 1. So that would make sense. Or like 4 minus 3 equals 1. And there should be, oh wait, but hold on. But then if we look at this draw command, so if we look here, so this draw command 2, if we try to do this calculation, so this first instance is 9, which is right here, and the instance count is 2, right? So it's going to look at 6 and 7, and then it'll do 7 minus 6, which is 1, which is actually the correct number. That's the correct visible instance count. And for the first element, it's just 0. Maybe, right? Like I'm doing something like that here, right? So like for the first draw, it's here, right? Instead of like doing draw and x not equal to 0, I'd do like if first instance not equal to 0, yeah, maybe. Because I guess that's how I got this to work. I just want to run through all this, but it's still a problem of this here 334, right? So this actually has 2 visible instances here, right? With this draw command 1, right? So your first instance starts at 2, right? So 0, 1, 2, and then there's 3 of them, so 1, 2, 3, right? But if I just do first instance plus instance count minus 1, right? So I would be looking at actually looking at 3. But then you get 4 minus 2 is 2. No, I think actually, because here I'm doing 0, 1, 2 plus 3 minus 1, which is 2, right? 1, 2. Yeah, so I'm looking here. So that's 4 minus prefix sum first instance, which is just into prefix sum minus first instance 0, 1, 2, which is 3, right? And then so this would equal 1 here. And then so in that case, I do need to do like first instance minus 1. Yeah, but then like, yeah, that's why I said subtract 1. Yeah, but then I think, let me fix that. Okay. But then I think, like if I change this around, so like if this was invisible, right? This was invisible here, or yeah, I think that's just how I have it up here. No. Well, like if this was invisible, then, oh yeah, then that would be 1. And then I think this is no longer correct. Right? Or no, yeah, it would be correct, right? Because now these are 2, and this is like 3 or whatever. Yeah, okay. And so it's still right. Okay, so that is first instance minus 1. Yeah, so basically what you said. Thanks. So it's probably this. So except if draw command first instance is not equal, can I type not equal to 0, and do it like this. Otherwise, then this should just be this. Yeah, I think this makes sense. I just kind of had to run through it, the whole thing, and check all the edge cases in my head. I think this will work. And this is basically the same thing I'm doing here, which also makes me think that it's correct. Yeah. Or, okay, well, hold on a second. This might be a little different. Yeah, I think this is fine. Yeah, this is probably just like, yeah, I think it's just like this, right? I even put a note here, like this probably doesn't need to be offset by first instance. Yeah, I've literally already done that. Pretty sure it's this, right? Because if, yeah, if this is 0, then it's just instance count, right? So if I look at this one, it's, yeah, if I look at index 2, that would be, or is this instance count -1? I think this is still instance count -1. Yeah. So now this would look at index 0, index 1, which would be 2, which is the number of visible instances here. I think this, well, this is, I don't think I need first instance because this is when first instance is 0, so it's not doing anything here. If I just kind of run through the math, it seems to make sense, right? Because I'm doing instance count -1 here. In case you want to start drawing in the middle somewhere. Yeah, all right, yeah. That's all right. I mean, I'm just kind of stumbling through this too. It's not really. You won't believe how long it took me to like figure this out the first time. I remember spending like just like a few days of staring at this and trying to figure it out. And then, yeah, before I did this, I didn't even know what a prefix sum was, and so I was looking up stuff like summing all integers on GPU or something, and eventually I found prefix sum. Eventually, I found stream compaction, and eventually I found like this mess of trying to do stream compaction and prefix sums on the GPU. And like I copy and pasted a lot of this code from here. I mostly understand how this works now, but anyway, let's test this out. So shader parsing failed. Oh, I'm gonna comment this stuff out again. All right, actually I need to run into render doc. Okay. So let's just see, does this, yeah, okay, so this all loads and that all looks reasonable, but I'm not touching anything. So like I'm not using the new one yet. So let's load this. And look at this. Here, move this out of the way. Or yeah, pipeline state, compute shader. So yeah, basically old and new should be exactly the same, unless there's a problem with the old one. It should be very annoying. Okay, hey, this looks pretty good. Yep, this all looks right. Yeah. Yeah, this looks good. Okay. And let me just move this over. Actually, you know what? Yeah, this is on like the wrong branch now or something, but this is good. And so I'm just gonna, I guess I can go ahead and commit this. That's fine, sort of. Rather not commit it because like eventually I'm gonna rebase onto master. I can stash it or something, but yeah, I'll just do like git stash. That's fine. Git add asset shaders draw pass, and then add objects, and then just stash it, and then do like reset. Yeah, and then I can switch to our yeah. Hold on. Doing things in the wrong order. Okay. So first off, let me just put this back. So I'm testing with a million objects, and that should fix some of this. Yeah, so that all still looks good. Great. Okay. I guess I'll just switch it over to this new algorithm. That's probably the best thing to do, and just totally get rid of this old one. That makes the most sense. Yeah. So we get rid of that, and then get rid of this, and then this is just a return. Yeah, this is the best way to do it. If else, what is this complaining about? Okay, there we go. Yeah, if instance count equals 0, return 0. If instance count is, first instance is not equal to 0, then return prefix sum of this, then return the prefix sum of that. Okay, now if this doesn't crash, then we're good. Hey, we didn't crash. Everything looks good. Yeah, and so now the culling code isn't exactly right. I have another branch I'm trying to do oriented bounding boxes instead of like I'm using like sphere frustum culling, but that's a different problem. That's not all this indexing mess. Okay, so that all looks good. Then let me just commit this. Oh yeah, and then I can get rid of these extra buffers here. So commit this to master, and then I can try it out in my rewrite branch. There we go. Better visible instance counting. There, and then I can just clear the stash, and then I can actually just like copy this. Just copy the whole thing. And then switch to the rewrite, and then it's now this file. Yep. And then I can just put this here, get rid of that, get rid of that. Yeah, that all looks good. Okay. So now I'm on the rewrite branch, and we can see if this crashes me. Hopefully not. But I know it works. I know this visible instance code is good now, because we tested on the old one. So if there's any like weird errors here, then that's just because of the, I'm doing something wrong somewhere else. With this rewrite code. I need to like dynamically link some of this stuff. Like sphere v cross is what I'm using for the shader reflection. I think that's like half of this compile time. It's just sphere v cross. So if I could dynamically link that instead of trying to do it statically, that'd be way better. Yeah. Why does my build take so long? I think it's just the delay. It's sphere v cross. It's not my code. Okay, this all... well, yeah, I think that's just the frustum culling code being broken. Yeah. Yeah, because I'm not seeing like random... Oh, hold on. I should still have some more... Maybe not. And also I have like two different renderers in like the same code, because instead, like on the rewrite branch, instead of just like starting from scratch, I just have like if new renderer. It's pretty terrible. But getting compute shaders working is like the last thing I need before I can merge everything. Yeah, so problem with that is yeah. Like, I'm pretty sure this should be like identical between the new one and the old one. I'm doing it here. Because this is like the old code here. And I'm just like doing the scale. I'm doing the sphere and frustum thing. And like some of this is a problem because I'm not taking into account like the actual object size. And so that's why there's like weird errors. Because I'm just looking at the scale and not like the absolute size. And like looking at the absolute size, that's what I'm trying to do with like oriented bounding boxes and all that. Yeah. And so this should be doing the same thing, but I don't know. Yeah, maybe I changed some of this stuff. I'm not sure. But anyway, let me turn on all of these extra objects. Let me see. Can I do it like that? Is that a thing in JSON? Probably not. I guess not. So yeah, go over this, run this. Okay, yeah, so I can run this with like a million extra cubes. And so you can see the frustum culling is very broken. But I'm not getting any crashes, and things are like showing up correctly. And so I think it's all good. It's just frustum culling is not correct. And there should be a model like here or something that I'm not seeing, but maybe it's just, oh yeah, I think I'm like setting the scale really small, or maybe it's big. I don't know. It's terrible. The frustum culling code is awful. But this is actually working. And so now I'm getting like 3,000 FPS looking at this. Let me see. Let me go up to like 10 million. Yeah, so even with like 10 million instances, I'm culling so much of it, I've still got 260 FPS. Without culling, I was getting like 30 FPS. Oh. Sweet. Yeah, let me go back to 1,000,000. Is that? Oh, yeah, that's fine. Or, yeah, that's good. That's good. That's good. Correct. Visible instances counting. Okay. So since all that seemed to be working, I'm pretty sure that's the last thing I needed to do before I actually merge all the code. I want to check my to-do list really quick. On my phone. I'm pretty sure this was like the last thing I needed for the rewrite, which I've been working on for a while now. Yeah, so I want IAMGUI, but that's fine. Yeah, synchronization, that's fine. Fixing render graph stuff. Yeah, okay. So basically, I just wanted to get with at feature parity with my old renderer before I got rid of everything. But now I'm pretty sure we're there because I can't think of anything else that I'm missing. And so now I can just delete like half the code in my code base. Great. Yeah, and then hold on. So there's also, why'd you rewrite it anyway? Oh yeah, let me show you. So you look here. So I can press like F2 and F3 to make this box show up. And the simple thing is that's why I rewrote it, because this didn't work in the old engine. And so the long answer is in the old engine. So we look here. I basically have to, yeah. I'm figuring out all of the indices for things when the engine first starts up, and I have no ability to like dynamically add and remove objects or instances or models or meshes or any of that, because like trying to calculate all of the IDs is just really complicated. And so what I rewrote pretty much everything for was to have support for custom memory allocation. And so I have under allocator, this is basically the reason why I had to rewrite everything, is to take into account custom memory allocation. So a lot of this code is copy and pasted, like this device initialization stuff. A lot of this is like exactly the same. But then like how I'm managing buffers and data and all that is like completely different now. And so I just kind of started from scratch rather than try to and copy it over the things I need, instead of trying to just jam it all into this old one. Yeah. And so like right here is a lot of where I'm like uploading all the instance data once. And then I'm like figuring out all the IDs for things. And I think I have to do like multiple passes. Like I have this first pass, and I have a second pass. Yeah, and then I'm sorting the draws, and then I'm finally uploading things. And then here I'm actually like defining buffers and stuff. And so this code was just not very dynamic. It was a lot simpler because I didn't have to deal with dynamically adding or moving things. But now I can just add or remove things. So like, yeah, so like if I want to add an object, you see, uploading everything at startup, going to have a dynamic section at the end, just at the end of the buffer. Yeah. So, yeah, it's a whole lot simpler to just put everything in startup. But yeah, if you have like fixed elements and dynamic elements, then you don't have to worry nearly as much about um, managing all of the pointers and stuff because you have like a small subset of things. But yeah, what I'm doing, I went completely dynamic for everything. Um, and so where is it? Like when I yeah, so like when I add an object, when I create an object, then I have to go to that GLTF model, basically like or the model, right? And then I go to add instance in here. And then this is where I'm actually going through now, like I'm iterating over all the nodes in the GLTF model and all the primitives and meshes and all that. And then for each GLTF primitive, I'm adding an instance. And then this is where it all comes together in this draw here. So this is okay. I'm like when I'm creating a new draw, which is like one GLTF primitive or like some section of vertices and indices and all that. So I go to my vertex buffer allocator and I allocate a size, whatever size I need for the vertices. Do the same thing for the indices, and like these allocators, they support reallocating the buffer, so I don't have to just figure out a fixed size for the vertex buffer at the beginning of the at the beginning of everything. I can just whenever the buffer goes over size, whenever the size is too small, it'll just call reallocate, and so it'll make me a new buffer, copy everything over, and then give me the extra space. Basically all this is just having like a C++ vector on the GPU. But actually getting this to work was pretty complicated. Yeah, like this is the one of the main allocators I'm using. And this allocator code is all terrible. Like it is. Like every time I look at this, I have to like pour through it just to figure out what I'm even doing here. Because like I'm like, there's all kinds of like multiple levels of inheritance, and just like trying to figure out what I'm. It's terrible. And everything's like templated, and yeah, it's a mess. But it works. So anyway, yeah. So then like in draw here, when I go to add an instance, then I go to like the instance data buffer allocator, and I allocate a block for instance data, and then I allocate like an index for it, and then yeah, and then I can like upload everything right to the GPU. Yeah, that's a lot of allocators. Yeah, in sub allocator here, yeah, like it's all kind of template, right? So I actually only have 4 of them. I can go a little, try to talk about this a little bit. So there's this void allocator. This basically just does nothing. And I forgot why I needed this. I think it was just like C++ was giving me some template error if I didn't have like some like default allocator. I don't remember. I needed this for something, but I'm not actually using it. So linear allocator, this one's like the simplest to understand. This just like gives me, it's like, hey, just give me a big block of memory on something. Yeah, and so this is where all the inheritance stuff gets complicated, because I want to be able to stack these allocators on top of each other. And so like this linear allocator, this has a parent. And this parent this could be another linear allocator, or it could be one of these allocators, or it could be a GPU allocator or a CPU allocator. I don't think I've actually used the CPU allocator all that much, but I just implemented it anyway because like I already did the GPU one. So, anyway, it's a mess of inheritance and templates and all that. Yeah, so this would take a parent. This could be like another allocator or like a GPU or something, and this would just allocate me a big block of memory. And then let's say on top of that, so like I have the GPU, and on top of that I have a linear allocator, and then on top of that I could put like a fixed allocator, and this will just allocate me a lot of fixed blocks within an allocation. And then all this supports like multi-threading and dynamic resizing. I've reinvented standard PMR. I have no idea what that is. Polymorphic allocator. Yeah, see, like I don't know enough about like more advanced C++ stuff to actually know how all this works. Oh man. Yep. Yeah, basically I reinvented this. Well, does this support? Okay, it doesn't support reallocate, but you can still build that into this. Yeah, and like I remember I tried looking into like I was looking a lot into like standard allocator to try to see like try to like figure out how this works, and I was thinking like, okay, maybe I could like use a maybe I could use like standard vector, but just give it like a GPU allocator or something like that. Um, but I didn't really figure all that out. But I will definitely look into this because maybe I can replace a lot of this mess with PMR. I should probably read, or what is it? It's is it learncpp.com? I'm sure this was like in here somewhere. Maybe, hopefully. Um, yeah, I should probably read through all of this. Yeah, it's probably in like the one of these, like the C++ 20 update or something. Yeah, I've implemented the same concept. Yeah, I just wish I knew about this because like I could at least use it as a reference for what I'm trying to do. Um, but this, I just basically figured all this stuff out myself. Um, yeah, and then the other sub allocator I have is this contiguous fixed allocator. This is basically just like a vector, and you can call like how you can call like vector dot erase, and it will everything will still be contiguous, and everything's like a fixed block size. And what I actually did with this is I'm pretty sure in the C++ vector, like when you call vector dot erase, it'll shift back all the elements by one. But instead, what I'm doing is pop and swap. And so, like if I remove an element from the middle, instead of shifting all the elements back one, I just take the last element and move it to the middle, and it works fine because I don't care about the order of elements. I just care it exists, right? So, like if this was for some model matrix, well, I don't care what the order of the model matrices is in the buffer. That doesn't matter. Like it's all indexed anyway. I just care that it exists in the buffer. Yeah, so this works pretty well. I don't know if this is like fully multi-threading. Like I wouldn't be surprised if there's like multi-threading errors in here, but I'm pretty sure it works. Yeah, time to just read all 9,000 pages of C++. Yeah, right. Because maybe there's even more stuff in there that'll do like exactly what I want. I just never heard of it before. Yeah, and so that's why I kind of rewrote all of this. Yeah, and then only 1,800 pages. Yeah. One thing though, with the frustum calling, let me yeah, I need to. If I just return true here, and then I have to disable optimizations because disable shader optimizations. Where is it in here? Where is it? Optimize. Because if I don't disable optimizations, I'm like manually writing to some pointers on for like push constants or something, and I get a seg fault when I don't. If I don't disable optimization, because if I return true here, then like I'm not using a bunch of these push constants, but I'm just like trying to write to the memory, and so it all gets screwed up. Yeah, but I want to make sure that everything else is showing up. If I'm just drawing all the instances. Let's see. Yeah, so this is what it would look like if the frustum culling code actually worked properly. Yeah, so I have and actually the reason these ducks are here is I couldn't find a good model for like a light bulb. Like I tried looking up like free like GLTF light bulb models, and I was just finding like it was either like way too complex, like it was like a street lamp or something, or a bunch of stuff was like paid, and I didn't want to deal with any of that. But then I saw this duck sample model. It's like, oh, that's fine for a light. And so I just have like a light here, and then I'm not doing like light occlusion or anything like that, right? So like it just like passes through the duck, basically. But yeah, I didn't know what else to use for the light model. So yeah, like right here, create light. Yeah, get light. Yeah. Anyway, yeah, and I've got animations working. This was like a test animation I found on the GLTF sample assets GitHub. And this like it's supposed to like really test your animation code. because if you have anything wrong, then like this like rotation will happen at the wrong time and things like that. Yeah, so most of these are just like little sample test models I've used to make sure that like the code I've written actually works. Oh yeah, another thing I want to do is on the old renderer, I'm using like query timestamps and things like that. And so I can actually see like how long the culling is taking and things like that. Yeah, but I might wait until I'll do that like after I merge everything. Yeah, because I'm also gonna like redo how the render graph works again. So on my old code, I just have all of these like wrapper functions around like every little Vulkan command that I want to use. And I thought, well, this is kind of ridiculous, right? Because these are basically doing like it's just so much boilerplate, right? And so on the new render graph, I tried coming up with these like complicated dynamic render nodes. Well, I mean, they're supposed to be simple, not complicated, right? And that I could just like pass any Vulkan function pointer into this, but it ended up being like actually trying to use it ends up being way more of a mess than just having like boilerplate functions, right? So what I have to do, I have to like create shared pointers for all the like Vulkan structs I need, and then I have to pass those into the node. It's like a lifetime to like hold the lifetime of it, and then I have to create a lambda function and pass all of it into the lambda function. Or I guess I don't actually need these because I can just pass, like I don't have to write here. I can just pass everything by reference, right? Or no, I can't. I don't think I can pass it by reference because it's actually passing like this stack allocated. I don't know, whatever. It's a mess, right? So I have like lambda functions that run, and then this will like do some kind of update on the actual Vulkan command, and then down here of like the Vulkan command and then any of its arguments. And this is just terrible. And also, if I want to figure out how to do like automatic memory barriers and synchronization. And the problem is I can't really do that if everything is in like shared pointers like this, because in order to make this actually work properly, you can do like type erasure on shared pointers. And so even though like this, I can say like, oh, this is a shared pointer to void. What it actually is like some Vulkan struct or a Vulkan function or something. But I can just turn it into a void pointer. However, that makes it really difficult to figure out like what resource is using, right? So like if I want to figure out synchronization, then I need to figure out which buffer is being used. And I can't really do that if everything's a void pointer, because I don't know what it is. I just know, oh, I can pass it to this Vulkan function, and the Vulkan function will magically do its thing. Yeah, so like I have add node, and then somewhere in here, there's like add dynamic node, which is even more complicated because like this is like a function to set the Vulkan function, and so I'm just going to go back to doing all of this boilerplate here. But yeah, I'm probably going to go ahead and merge all the new code. And then if I want to like copy paste stuff, I can just look it up on GitHub or something, or the Git log. But what was really important is just getting like feature parity with the old engine. So now I have all this stuff. And yeah, I don't have the timestamps right up here, but that's very minor. I'm actually rendering everything and doing all the compute shaders and stuff. And that's what was complicated, and being able to dynamically add and remove things. So yeah, then I guess I can go ahead and start just ripping out code. So that's going to be awesome. No, I don't want that. No, I don't want that. Okay. So, yeah, I can just start delete. Yeah, I can delete this whole folder. That's awesome. Make sure I delete the right folder, but it's all in Git anyway, so it doesn't matter. Right, so this whole folder should be gone. Great. And then I can delete the GLTF folder. Yeah, because oh man, I almost don't want to delete this code because GPU doesn't support for performance queries. Oh man. Yeah. So for the old renderer, I wrote my own GLTF model loader. And it works well enough. But I decided to switch over to using the fast GLTF library, since it should be fast. And I didn't like trying to maintain all of this like JSON parsing stuff for all this. Like this is just a lot of really annoying, tedious boilerplate to maintain. Um, but I also don't want to delete all this stuff just because I remember. I don't know if you know anything about GLTF files, but the accessors are kind of complicated. Um, and I remember being like very proud of writing this accessor loader class because it does like all kinds of stuff to like dynamically figure out types for things, and it's pretty awesome. Um, I think mine's actually better than the one in Fast GLTF because this has like even better type inference than that one does. But anyway, yeah, and it's just like all templated header file stuff, and it's definitely maybe could be better because I have all these like structs that are like copy pasted. I can make like a macro or something, but yeah, but I don't need any of this code anymore, so I might as well just delete it. I just don't want to delete it because yeah, because I actually enjoyed writing this, or like I don't know. Yeah, it'll still be my Git history, I guess. Okay, so I'm not using it anymore. All right, let me get rid of that. GLTF. Yep. There we go. And goodbye. Okay, now memory allocate. Yeah, so I just have renderer, utils. That's fine. That's fine. Yeah, so external. So yeah, I definitely want to start dynamically linking spear v cross because this is like at least half the compile time. I don't even know. Yeah, maybe GL slang as well because that's probably also big. Yeah, all this stuff. Yeah, the rest of this. Oh yeah, and then I can get rid of some of these shader files up here. I like have 2 copies of the shader files. That annoyed me yesterday because since I have 2 copies of them, I was trying to edit it and I was editing the wrong file, and I was like, oh, why isn't this working? Yeah, so get rid of all that, and then get rid of all that. There we go. Now I just have the new folder set up. All right. I can get rid of these perf files. It just doesn't, but that's kind of separate. Once you build a static library, compile time, should it matter? Yes, except for, so like you saw earlier, my compile time was really slow because I had switched branches. And so like it had to recompile, like I'd switched to master and that was kind of fast. And then I switched back to the rewrite and I had to recompile everything. And then also like if I ever change the compile flags, like sometimes I want to like totally disable optimizations. Or like if I go between debug and release, then it has to recompile everything and it's really slow. And like I should be dynamically linking anyway. Like that should theoretically be better. I would think. Yeah, the rest of this is fine. Yeah, it's mostly new stuff anyway. Yeah. Okay, now it's time to go in here. And this is going to be very upset at me because a whole bunch of code probably doesn't exist anymore. Yeah, okay, that's like some stupid Clang error. That doesn't matter. Yeah, so now I want to get rid of like all these unused imports, pretty much. Get rid of all that. Get rid of that. Get rid of all of that. Get rid of that. Yeah, some of these I might actually need, but they're unused imports, and so while I'm cleaning up everything, I might as well do it all right now. Get rid of that. What's your engine called? Yeah, it's Open4X. So I'm 4X no, I mean there's like 4X game genre. Right? So it's like I'm eventually going to make like some kind of like space strategy game, like I think like I don't know, like Elite Dangerous, and there's X4 Foundations, which is 4X game, but it's called X4. Yeah, like Elite Dangerous, X4 Foundations, kind of Stellaris, sort of. Really, I'm just going to try to like put everything I've ever wanted into a video game into this, and that's also why I'm making my own engine. Part of this is like I want it to be tally open source. Like Godot is open source, but also like I'm not sure wasn't really sure about like how, like I'd probably like end up forking Godot and like having a whole bunch of custom stuff into it. So I'm like, all right, I'm just gonna make my own engine. Um, yeah, and now I can like do whatever I want with it anyway. Yeah. So yeah, and this is upset. Yeah, like for whatever reason, like Clang has some. I think I filed a bug report with this, and they said they like won't fix it. So like I'm using Clang for the language server, and Clang doesn't like some of the stuff I'm doing. It's not even loading now, but yeah, I get like weird errors sometimes from Clang. I think it's yeah, yeah. I think I delete everything. Clang's not happy, but anyway, yeah. So this error doesn't matter. Creation time. Oh wait, maybe I need that one. Maybe I should have got rid of that. So if new renderer, so it's always the new renderer. New window, unknown time name window. Okay. Yeah, there's probably some imports I shouldn't have deleted. But that's fine because I do want to get rid of all the unused imports. Fill compute push constants. Yep, get rid of that. Custom constants. Yeah, that's fine. Settings. Right, so I should have done that. Or yeah, okay, so yeah, so this is called new settings, right? But I don't want to do that anymore. I just want to rename this to just be settings because I didn't use namespaces and whatever. Can I just do this? Mostly. Let's get rid of that. Get rid of that. Is this fine? Yeah, that looks fine. Let's go back here. Okay. So what do I need to do here? Equals settings, extra object count. Okay, so this needs to be this. Right? Yeah, and then rand limit is this. And then show FPS is this. Or, yeah, whatever. Yeah, so now, yeah, we did all the fun parts. Now I'm just cleaning up code, so. Yeah, we got the shaders working, which is great. But I mean, maybe it's fun to watch me delete all these lines. I don't really know. So I got rid of an import I didn't need to get rid of. Settings. That's fine. Am I deleting that? No. Okay. Or, okay, yeah, and this shouldn't be called new settings. It should just be called settings. Got kind of nerd snap. Yeah, yeah. Man, I only learned what that was the other day. Now I'm hearing it again. All right. But I mean, I guess it's kind of the point of this stream. Like, that's how I'm gonna get people in. It's just start working on like difficult problems. Or yeah, maybe that's the real strategy to get a lot of followers. Is I just have to like be like kind of bad. It's like when you post, if you like you put, there's that meme about like posting a wrong answer on Stack Overflow, and that's how you get all the responses. Do something like that, and that's how I get a whole bunch of people commenting and all that. Anyway, okay, so this is a lot cleaner now. Yeah, I'll leave that. No, just get rid of that. It's fine. So, I'm missing a whole bunch of things. Am I using creation time anywhere? Yes. Okay. So I still need this, but I want to rename you like that. And I need to import window. So include renderer Vulkan window. Yeah, there we go. Here's window. And then, or not window? What? Renderer Vulkan window not found. It's right here. What are you talking about? Oh. Always something stupid like that. Okay, so there's window. So settings, undeclared identifier. Oh wait, this is a shared point. What am I doing here? This is terrible. Why? Okay, this just doesn't even need to be shared pointer in the first place. Yeah. All right, so let me just include, what is this, common? So, renderer, Vulkan, common HPP, I think. And then this is just settings. Rend. Oh. Yeah, like that. Okay, and then is settings showing up now? Yes. Okay, and then I need rapid JSON stuff. Right, and then this is no longer a shared pointer. I don't know why I ever did that in the first place. Creation time, yeah, I need that. Let me get the rapid JSON stuff. Where else am I doing that? Shader, I think. Yeah, I think I need some of these. I don't know which ones. Everything step writer? Okay, that kind of makes sense. Okay, and then I need object. Oh no, this is still broken. Why is it still broken? Oh, because I'm not using rapid JSON. Yeah, that's fine. I'll just do it like this. I actually want to try switching from rapid JSON to SIMD JSON because it's supposed to be faster. Now, I mean, these are just small config files, but I just want to try it out and see if it's any better. Because I kind of hate the interface for actually trying to use rapid JSON. So maybe SIMD JSON is easier to use. Okay, creation time. I need to create that variable. Yeah, what would that even be? You have like auto everywhere. What does this return? Time point. Yeah, so it's like, yeah, time point, system clock. I can't just copy paste from down there because when I move the mouse, it gets rid of it. It's awful. Settings, it should be show FPS. Yeah. Yeah, this is the right code. Okay. Heard YY JSON, faster still. Now I thought SIMD JSON had some benchmarks, but yeah, if YY JSON has like a better, I care. Since all the files I'm dealing with, at least right now, are really small, since I'm not doing GLTF loading anymore, I care more about how easy it is to use, because rapid JSON is just like awful to use. It's terrible. But anyway, yes, let me see. Yeah, so this has benchmarks on here for YY JSON, but like maybe this is different. Maybe they're benchmarking it differently. I'm not sure. But anyway, that's kind of a side thing. So load sends, yeah, and so all this, a bunch of these, I want to change this. I've decided to switch to snake case for most things. So there's that. Yeah. And then this stuff, this should be set frustum cam const. This is set frustum const. Okay. So now I need object and creation time. Is that it? Yes, that's it. No man JSON, but the performance stable. Okay. I mean, like I still need to be reasonably fast, so I just need not rapid JSON for the interface. It's just so bad. So this said this was like a time point or something. I think I did this somewhere else. Yeah, in the animations, I think I'm dealing with time points or something like that. Or no, was I just converting? Yeah, I think I was converting everything to a uint actually, so I didn't have to deal with the time point thing. Yeah, but let me see this because this is what is this? What is the type here? Please tell me the type. It's Clang so bad. Is there just like describe type? Go to type definition. It's not exactly it. CL describe type. It's the LSP type. Let's just see what this does. No. I mean, okay. Oh, this is just a type def. Type def time point. System clock. All right, what is this again? This is, no, I have to look at the auto, this. What does auto say? Time point, chrono, system clock, duration. Okay, I think I just do chrono system clock actually. I think that was it. So I say like time point of standard chrono system clock. Call this creation time. Did you mean standard chrono time point? Yes, I did. There we go. Does that work now? Okay, so I've got 4 compile errors apparently. Where is it? Show all errors. There we go. Yeah, so there's this stupid thing, template argument. This is Clang is broken. Vulkan object. Wait, what? Oh, yeah, I think it should just be object. And this should be like right vector or something. Let me look at this. Or no, I think I defined these in the camera actually. Yeah, I defined them in the camera. Okay. All right. There we go. Yeah, there we go. Okay, so that is everything except the stupid Clang error. Great. Anything else I need to fix? Right, I wanted to clean up. Are there like any more unused imports? Yeah, so okay, so there's some more problems. Unknown new settings. Did you mean settings? Yep. So that's in renderer. Yeah, just save that. When I did the refactor, fixed all that. I don't need the light in here. Okay. That looks good. Let me just go through everything else and see if there's any unused imports. Just look at every file. Did that take a second to load? Yeah, okay. Just want to, like, while I'm here, I might as well get rid of any unused imports. Oh, save that file. Still have a problem? Unknown identifier settings. That should have worked. I thought I passed under graph. If settings. Probably need to rename something. Ah, I need to save common. That's what it is. Okay. There we go. Yeah. Error's gone now. Or it's wrong file. There we go. That fixed it. Okay. Renderer, no unused imports. Pipeline. This load. Come on. Okay, yeah. So this is where Clang is very mad at me. Let me see if I can try to fix this real quick. So what this chunk processor is this lets me take like a vector and perform like a single operation on it across many threads. So like this is how I'm creating objects, right? So if I want to create a million objects, then I can just hand it this chunk processor and give it this lambda function that'll create an object, and then that'll just run across all the threads, and it'll like split everything up, right? So like I'm doing objects of I. And so just like I is like the the not exactly the thread ID, but like the thread IDs go from like they go from like 0 up to like, or from like I split up. I do like a million divided by 14 or something, and I like do like batches of that across all the threads. I don't know if that makes any sense, but anyway, and Clang, it likes it up here, which I guess is because I'm giving it a type. But it doesn't like it here. Oh yeah, I think it's something because of like it's not actually my thing. It's like it doesn't like me passing standard vector as a as like a template argument. And like this thing is actually like silently passing vector. Let me see. I think it's in I think this is in utils. Yeah, down here, yeah. So thread pool, chunk processor. Yeah. So it takes yeah, so it's by default a vector. But then like okay, maybe this is trying to say like vector of t. Does that fix it? Default template argument for template parameter must be a class template. Oh man. Class CT template. Maybe I just don't want to say template. No, because I wonder if I just get rid of that by default. If I just don't have a default. Okay. And GCC is just fine with this. Oh, now it's okay. Too few arguments. Okay, now what if I do standard vector? Okay, what if I do standard vector of object pointers? Template argument for template parameter must be a class template or type alias template. Template argument has different template parameters and its corresponds. This is terrible. Yeah, but this works on GCC, but Clang it doesn't work on, and I'm pretty sure they said they won't fix it. Yeah. Let me just change this back to how it was before. Yeah, just default to vector or whatever. Or, yeah, like that. Okay. So, yeah, that's not going to get fixed. Space allocator, utils. Yeah, more stupid stuff with Clang. Does I have 3 errors? Oh, GPU allocator when I undeclared identifier. So I think I need to include allocator. I think it's base allocator. Yeah, there we go. So I just have access to global variable. I hate how I have these like global variables I'm passing everywhere, but it works for now. Okay, object. That all looks good. About this, that looks good. File manager. This one I need to save. Oh, and actually, I have something to do in a few minutes, so I'll be leaving within a few minutes. I'll be back on Friday from 5 to 9 or 5 to 7. I don't know. It's all on my schedule down below. Yeah, but I will be going in a few minutes. And I'll finish. Yeah, well, I want to get this to compile and like commit this first. And then yeah, but then after that, yeah, it's like 2 a.m. there now. Yeah. Oh, yeah, I'm not using globals or anything. I'll leave this one alone. That one's fine. Okay. What was that? Memcopy? Include, isn't it like C string or something? Yeah. Okay, that should be all the unused imports and everything, so you should be able to compile this. Failed. Okay. See out. Okay, I just need to add new settings. Okay, this is warnings from Vulkan memory allocator. Yeah, that's fine. Yeah, so Object Manager 15. Yeah, new settings should just be called settings. Clang wasn't telling me about this because Clang just like freaks out about this whatever template thing it's going on here. So it wasn't telling me about this error. But that should be fine. And then in here, an image on. Oh, I just need C out. Yeah, warning. Yeah. Okay. Or include IO stream. That should work. Okay, let's run it. And I segfault it. What? Why did you segfault? Oh. I did something really stupid. What? Can you tell me? No, you can't tell me. Well, yeah, but that exists. Is it settings? I imagine it's segfaulted on settings. Yeah, it's segfaulted on settings. Okay. Is this model manager? Line 12. How did you segfault? I guess I'm not. Am I not calling load settings early enough? That's probably it. This is probably how I've like global pointers everywhere. I hate it, but I haven't come up with a good solution otherwise. No, I am calling load settings first. Model manager. Load settings. Settings equals new settings. Oh, wait a second. Oh, I see. Yeah, I'm shadowing it here. That's what's going on. I shouldn't have done that. Yeah, and get rid of common in there. Is that still going to work? Yeah, other things should import common, I guess. Here we go. Hey, it all works. Yeah, I mean, Frustum calling's broken, but everything else works. So I wonder, how long does it take if I just do make clean, get rid of all that? How long does just like a clean build take? Yeah, so I still have like 120 files, but pretty sure that was bigger earlier. I mean, it should have been worse earlier. But I think a lot of this, yeah, this is all spear v cross right now. Like it's not even doing my code and GL slang. And yeah, I think I saw a few pieces of my code in there, but yeah, this is all just dependencies. So I can definitely fix a lot of this with dynamic linking. Yeah, and then that'll make compiles go way faster. Instead of 120, this will be like 30. Any faster with make.j? This is on multiple cores. I think it's not on all the cores because I have a 13600KF. It's one of the newer Intel CPUs, and it was having problems. I was having like crashing, or no. I was just running out of RAM. Yeah, that's what it was. So even though I have I'm having crashing issues to get my CPU replaced, but that's separate. I do have 64 gigs of RAM, but when I was running it on like all like 20 cores of the CPU, it was crashing. So I think, let me see, how many am I running this on? Is it in here? I have like a make file and a CMake file. It's kind of stupid. Or no, I think I might be running it on every core. Yeah. Okay, yeah, I think I am running it on all 20 cores. Now, only like 6 of those cores are like performance cores or something, but or 20 threads, whatever. Yeah, so it seems to be running all 20 threads and it's still really slow. But that's just because of spear v cross and GL slang, which I should be able to dynamically link, I hope. But since this all works, man, this is a huge commit. Yeah, just add everything. Remove old engine and unused imports. Woo! How many changes was that? 55 files changed, 200 insertions, 7,000 deletions. You have unfortunate news? Oh, are we not doing things later? Because I was about to get off and jump on Discord. It's Monday. Yeah, I know it's Monday. Yeah, I'm about to get off for D&D. I was just a few minutes late. Anyway, yeah. Um, so yeah, I will be back on Friday at 5 p.m. Yeah. So